A radio is a device that allows you to listen to various audio programs and music. It operates by receiving and converting signals transmitted through the airwaves into sound. The first radio was invented in the late 19th century and has become an integral part of our daily lives. It is available in various forms, such as tabletop, portable, and car radios. Radios provide news, sports, music, and entertainment, which is one of their biggest advantages. Radios now include Bluetooth, internet radio, and other functions. Tuning into your favorite radio station is effortless. Select the station's frequency, and you're set. You can also find several preset stations to switch between them. A radio is a valuable device that provides a convenient way to access a wealth of audio content. Whether in the car, at home, or on the go, the radio is always there to keep you entertained and informed. Radio technology has been a source of entertainment and communication for many years. Have you ever wondered how it works? Let's explore the step-by-step process of how a radio functions. Broadcasting: a radio station sends a signal by transmitting an audio message through the airwaves. This signal travels through the atmosphere and gets picked up by your radio. Antenna: your radio has an antenna that captures the signal. This antenna converts the electromagnetic waves into an electrical current. Tuner: the tuner inside your radio handles selecting a specific frequency and isolating it from other signals. Amplifier: once the signal is captured by the antenna and selected by the tuner, it is amplified to a level that can drive your radio speakers. Decoding: the radio decodes the signal into an audio message sent to the speakers. This process transforms the electrical current into sound waves that your ears can hear. Speakers: the speakers in your radio convert the electrical signal into sound waves that can get heard. The radio broadcasts an audio signal, capturing it with an antenna and then selecting it with a tuner, amplifying it, and decoding it, and finally converting it into sound waves with speakers. The technology behind the radio is simple yet powerful. It has allowed people to stay connected and entertained for many years. Radio is the technology of signaling and communicating using radio waves. Radio waves are electromagnetic waves of frequency between 3 Hz, Hz, and 3000 GHz, GHz. They are generated by an electronic device called a transmitter connected to an antenna which radiates the waves, and received by another antenna connected to a radio receiver. Radio is widely used in modern technology, in radio communication, radar, radio navigation, remote control, remote sensing, and other applications. In radio communication, used in radio and television broadcasting, cell phones, two-way radios, wireless networking, and satellite communication, among numerous other uses, radio waves are used to carry information across space from a transmitter to a receiver, by modulating the radio signal, impressing an information signal on the radio wave by varying some aspect of the wave, in the transmitter. In radar, used to locate and track objects like aircraft, ships, spacecraft, and missiles, a beam of radio waves emitted by a radar transmitter reflects off the target object, and the reflected waves reveal the object's location. In radio navigation systems such as GPS and VOR, a mobile navigation instrument receives radio signals from navigational radio beacons whose position is known, and by precisely measuring the arrival time of the radio waves the receiver can calculate its position on Earth. In wireless radio remote control devices like drones, garage door openers, and keyless entry systems, radio signals transmitted from a controller device control the actions of a remote device. The noun radio is also used to mean a broadcast radio receiver. Like the computer and other inventions, the radio has many different inventors because it takes more than one technology to work like the device we know today. The radio music player, as we know it today, is primarily credited to Guglielmo Marconi and Nikola Tesla. Both men fought over patent rights to the radio communications used with the radio telegraph. However, without the tube diode and vacuum tubes inventions by John Fleming, the radio would also not be what it is today. In 1906, Reginald Fessenden made the first AM, amplitude modulation, radio broadcast. The first commercial radio broadcast began on November 2, 1920, in the United States, Pittsburgh, PA. Edwin Armstrong invented the FM, frequency modulation, radio in 1933. On September 25, 2001, XM radio, a satellite radio service, became available. The existence of radio waves was first proven by German physicist Heinrich Hertz on November 11, 1886. In the mid-1890s, building on techniques physicists were using to study electromagnetic waves, Guglielmo Marconi developed the first apparatus for long-distance radio communication, sending a wireless Morse code message to a recipient over a kilometer away in 1895, and the first transatlantic signal on December 12, 1901. Carl Ferdinand Braun invented the phased array antenna in 1905. The first commercial radio broadcast was transmitted on November 2, 1920, when the live returns of the Harding-Cox presidential election were broadcast by Westinghouse Electric and Manufacturing Company in Pittsburgh, under the call sign KDKA. The emission of radio waves is regulated by law, coordinated by the International Telecommunication Union, ITU, which allocates frequency bands in the radio spectrum for various uses. The word radio is derived from the Latin word radius, meaning spoke of a wheel, beam of light, ray. It was first applied to communications in 1881 when, at the suggestion of French scientist Ernest Mercader Fr., Alexander Graham Bell adopted radiophone, meaning radiated sound, as an alternate name for his photophone optical transmission system. Radio waves are radiated by electric charges undergoing acceleration. They are generated artificially by time-varying electric currents, consisting of electrons flowing back and forth in a metal conductor called an antenna. As they travel farther from the transmitting antenna, radio waves spread out so their signal strength, intensity in watts per square meter, decreases, so radio transmissions can only be received within a limited range of the transmitter, the distance depending on the transmitter power, the antenna radiation pattern, receiver sensitivity, noise level, and presence of obstructions between transmitter and receiver. An omnidirectional antenna transmits or receives radio waves in all directions, while a directional antenna or high-gain antenna transmits radio waves in a beam in a particular direction, or receives waves from only one direction. Radio waves travel at the speed of light in vacuum. The other types of electromagnetic waves besides radio waves, infrared, visible light, ultraviolet, X-rays and gamma rays, can also carry information and be used for communication. The wide use of radio waves for telecommunication is mainly due to their desirable propagation properties stemming from their large wavelength. In radio communication systems, information is carried across space using radio waves. At the sending end, the information to be sent is converted by some type of transducer to a time-varying electrical signal called the modulation signal. The modulation signal may be an audio signal representing sound from a microphone, a video signal representing moving images from a video camera, or a digital signal consisting of a sequence of bits representing binary data from a computer. The modulation signal is applied to a radio transmitter. In the transmitter, an electronic oscillator generates an alternating current oscillating at a radio frequency, called the carrier wave because it serves to carry the information through the air. The information signal is used to modulate the carrier, varying some aspect of the carrier wave, impressing the information on the carrier. Different radio systems use different modulation methods. Amplitude modulation. In an AM transmitter, the amplitude, strength, of the radio carrier wave is varied by the modulation signal. FM, frequency modulation. In an FM transmitter, the frequency of the radio carrier wave is varied by the modulation signal. FSK, frequency shift keying, used in wireless digital devices to transmit digital signals, the frequency of the carrier wave is shifted between frequencies. OFDM, orthogonal frequency division multiplexing, a family of digital modulation methods widely used in high-bandwidth systems such as Wi-Fi networks, cell phones, digital television broadcasting, and digital audio broadcasting, DAB, to transmit digital data using a minimum of radio spectrum bandwidth. It has higher spectral efficiency and more resistance to fading than AM or FM. In OFDM, multiple radio carrier waves closely spaced in frequency are transmitted within the radio channel, with each carrier modulated with bits from the incoming bit stream, so multiple bits are being sent simultaneously, in parallel. At the receiver, the carriers are demodulated and the bits are combined in the proper order into one bit stream. Many other types of modulation are also used. In some types, a carrier wave is not transmitted but just one or both modulation sidebands. The modulated carrier is amplified in the transmitter and applied to a transmitting antenna which radiates the energy as radio waves. The radio waves carry the information to the receiver location. At the receiver, the radio wave induces a tiny oscillating voltage in the receiving antenna which is a weaker replica of the current in the transmitting antenna. This voltage is applied to the radio receiver, which amplifies the weak radio signal so it is stronger, then demodulates it, extracting the original modulation signal from the modulated carrier wave. The modulation signal is converted by a transducer back to a human usable form. An audio signal is converted to sound waves by a loudspeaker or earphones, a video signal is converted to images by a display, while a digital signal is applied to a computer or microprocessor, which interacts with human users. The radio waves from many transmitters pass through the air simultaneously without interfering with each other because each transmitter's radio waves oscillate at a different rate. In other words, each transmitter has a different frequency, measured in hertz, kilohertz, kilohertz, megahertz, or gigahertz, gigahertz. The receiving antenna typically picks up the radio signals of many transmitters. The receiver uses tuned circuits to select the radio signal desired out of all the signals picked up by the antenna and reject the others. A tuned circuit, also called resonant circuit or tank circuit, acts like a resonator, similar to a tuning fork. It has a natural resonant frequency at which it oscillates. The resonant frequency of the receiver's tuned circuit is adjusted by the user to the frequency of the desired radio station. This is called tuning. The oscillating radio signal from the desired station causes the tuned circuit to resonate, oscillate in sympathy, and it passes the signal on to the rest of the receiver. Radio signals at other frequencies are blocked by the tuned circuit and not passed on. A modulated radio wave, carrying an information signal, occupies a range of frequencies. The information, modulation, in a radio signal is usually concentrated in narrow frequency bands called sidebands, SB, just above and below the carrier frequency. The width in hertz of the frequency range that the radio signal occupies, the highest frequency minus the lowest frequency, is called its bandwidth, BW. For any given signal-to-noise ratio, an amount of bandwidth can carry the same amount of information, data rate in bits per second, regardless of where in the radio frequency spectrum it is located, so bandwidth is a measure of information carrying capacity. The bandwidth required by a radio transmission depends on the data rate of the information, modulation signal, being sent, and the spectral efficiency of the modulation method used, how much data it can transmit in each kilohertz of bandwidth. Different types of information signals carried by radio have different data rates. For example, a television, video, signal has a greater data rate than an audio signal. The radio spectrum, the total range of radio frequencies that can be used for communication in a given area, is a limited resource. Each radio transmission occupies a portion of the total bandwidth available. Radio bandwidth is regarded as an economic good which has a monetary cost and is in increasing demand. In some parts of the radio spectrum, the right to use a frequency band or even a single radio channel is bought and sold for millions of dollars. So there is an incentive to employ technology to minimize the bandwidth used by radio services. A slow transition from analog to digital radio transmission technologies began in the late 1990s. Part of the reason for this is that digital modulation can often transmit more information, a greater data rate, in a given bandwidth than analog modulation, by using data compression algorithms, which reduce redundancy in the data to be sent, and more efficient modulation. Other reasons for the transition is that digital modulation has greater noise immunity than analog. Digital signal processing chips have more power and flexibility than analog circuits, and a wide variety of types of information can be transmitted using the same digital modulation. Because it is a fixed resource which is in demand by an increasing number of users, the radio spectrum has become increasingly congested in recent decades, and the need to use it more effectively is driving many additional radio innovations such as trunked radio systems, spread spectrum, ultra-wideband, transmission, frequency reuse, dynamic spectrum management, frequency pooling, and cognitive radio. The airwaves are a resource shared by many users. Two radio transmitters in the same area that attempt to transmit on the same frequency will interfere with each other, causing garbled reception, so neither transmission may be received clearly. Interference with radio transmissions can not only have a large economic cost, but it can also be life-threatening, for example, in the case of interference with emergency communications or air traffic control. To prevent interference between different users, the emission of radio waves is strictly regulated by national laws, coordinated by an international body, the International Telecommunication Union, ITU, which allocates bands in the radio spectrum for different uses. Radio transmitters must be licensed by governments, under a variety of license classes depending on use, and are restricted to certain frequencies and power levels. In some classes, such as radio and television broadcasting stations, the transmitter is given a unique identifier consisting of a string of letters and numbers called a call sign, which must be used in all transmissions. In order to adjust, maintain, or internally repair radio telephone transmitters, individuals must hold a government license, such as the General Radio Telephone Operator License in the U.S., obtained by taking a test demonstrating adequate technical and legal knowledge of safe radio operation. Exceptions to the above rules allow the unlicensed operation by the public of low-power short-range transmitters in consumer products such as cell phones, cordless phones, wireless devices, walkie-talkies, citizens band radios, wireless microphones, garage door openers, and baby monitors. In the U.S., these fall under Part 15 of the Federal Communications Commission, FCC, regulations. Many of these devices use the ISM bands, a series of frequency bands throughout the radio spectrum reserved for unlicensed use. Although they can be operated without a license, like all radio equipment, these devices generally must be type approved before the sale. Broadcasting is the one-way transmission of information from a transmitter to receivers belonging to a public audience. Since the radio waves become weaker with distance, a broadcasting station can only be received within a limited distance of its transmitter. Systems that broadcast from satellites can generally be received over an entire country or continent. Older terrestrial radio and television are paid for by commercial advertising or governments. In subscription systems like satellite television and satellite radio, the customer pays a monthly fee. In these systems, the radio signal is encrypted and can only be decrypted by the receiver, which is controlled by the company and can be deactivated if the customer does not pay. Broadcasting uses several parts of the radio spectrum, depending on the type of signals transmitted and the desired target audience. Long-wave and medium-wave signals can give reliable coverage of areas several hundred kilometers across, but have a more limited information carrying capacity and so work best with audio signals, speech and music, and the sound quality can be degraded by radio noise from natural and artificial sources. The short-wave bands have a greater potential range but are more subject to interference by distant stations and varying atmospheric conditions that affect reception. In the very high frequency band, greater than 30 MHz, the Earth's atmosphere has less of an effect on the range of signals, and line-of-sight propagation becomes the principal mode. These higher frequencies permit the great bandwidth required for television broadcasting. Since natural and artificial noise sources are less present at these frequencies, high-quality audio transmission is possible, Using frequency modulation. Radio broadcasting means transmission of audio, sound, to radio receivers belonging to a public audience. Analog audio is the earliest form of radio broadcast. AM broadcasting began around 1920. FM broadcasting was introduced in the late 1930s with improved fidelity. A broadcast radio receiver is called a radio. Most radios can receive both AM and FM. AM, amplitude modulation. In AM, the amplitude, strength, of the radio carrier wave is varied by the audio signal. AM broadcasting, the oldest broadcasting technology, is allowed in the AM broadcast bands, between 148 to 283 kHz in the low frequency, LF, band for long-wave broadcasts and between 526 to 1706 kHz in the medium frequency, MF, band for medium-wave broadcasts. Because waves in these bands travel as ground waves following the terrain, AM radio stations can be received beyond the horizon at hundreds of miles distance, but AM has lower fidelity than FM. Radiated power, ERP, of AM stations in the US is usually limited to a maximum of 10 kilowatts, although a few, clear channel stations, are allowed to transmit at 50 kilowatts. AM stations broadcast in monaural audio. AM stereo broadcast standards exist in most countries, but the radio industry has failed to upgrade to them, due to lack of demand. Shortwave broadcasting, AM broadcasting is also allowed in the shortwave bands by legacy radio stations. Since radio waves in these bands can travel intercontinental distances by reflecting off the ionosphere using skywave or skip propagation, shortwave is used by international stations, broadcasting to other countries. FM, frequency modulation. In FM the frequency of the radio carrier signal is varied slightly by the audio signal. FM broadcasting is permitted in the FM broadcast bands between about 65 and 108 MHz in the very high frequency, VHF, range. Radio waves in this band travel by line of sight, so FM reception is limited by the visual horizon to about 30 to 40 miles, 48 to 64 kilometers, and can be blocked by hills. However, it is less susceptible to interference from radio noise, RFI, spherics, static, and has higher fidelity, better frequency response, and less audio distortion than AM. In the US, radiated power, ERP, of FM stations varies from 6 to 100 kilowatts. Digital radio involves a variety of standards and technologies for broadcasting digital radio signals over the air. Some systems, such as HD radio and DRM, operate in the same wavebands as analog broadcasts, either as a replacement for analog stations or as a complementary service. Others, such as DAB/DAB+ and ISDB_TSB, operate in wavebands traditionally used for television or satellite services. Digital audio broadcasting, DAB, debuted in some countries in 1998. It transmits audio as a digital signal rather than an analog signal as AM and FM do. DAB has the potential to provide higher quality sound than FM, although many stations do not choose to transmit at such high quality, has greater immunity to radio noise and interference, makes better use of scarce radio spectrum bandwidth, and provides advanced user features such as electronic program guides. Its disadvantage is that it is incompatible with previous radios, so that a new DAB receiver must be purchased. Several nations have set dates to switch off analog FM networks in favor of DAB/DAB+, notably Norway in 2017 and Switzerland in 2024. A single DAB station transmits a 1500 kHz bandwidth signal that carries from 9 to 12 channels of digital audio modulated by OFDM, from which the listener can choose. Broadcasters can transmit a channel at a range of different bit rates, so different channels can have different audio quality. In different countries, DAB stations broadcast in either band 3, 174 to 240 MHz, or L band, 1.452 to 1.492 GHz, in the UHF range, so like FM reception is limited by the visual horizon to about 40 miles, 64 kilometers. HD radio is an alternative digital radio standard widely implemented in North America. An in-band on-channel technology, HD radio broadcasts a digital signal in a subcarrier of a station's analog FM or AM signal. Stations are able to multicast more than one audio signal in the subcarrier, supporting the transmission of multiple audio services at varying bit rates. The digital signal is transmitted using OFDM with the HDC, high-definition coding, proprietary audio compression format. HDC is based on, but not compatible with, the MPEG-4 standard HEAAC. It uses a modified discrete cosine transform, MDCT, audio data compression algorithm. Digital Radio Mondiale, DRM, is a competing digital terrestrial radio standard developed mainly by broadcasters as a higher spectral efficiency replacement for legacy AM and FM broadcasting. Mondiale means worldwide in French and Italian. DRM was developed in 2001, and is currently supported by 23 countries, and adopted by some European and Eastern broadcasters beginning in 2003. Satellite radio is a subscription radio service that broadcasts CD-quality digital audio direct to subscribers' receivers using a microwave downlink signal from a direct broadcast communication satellite in geostationary orbit 22,000 miles, 35,000 kilometers, above the Earth. It is mostly intended for radios in vehicles. Satellite radio uses the 2.3 GHz S-band in North America. In other parts of the world, it uses the 1.4 GHz L-band allocated for DAB. Television broadcasting is the transmission of moving images by radio, which consist of sequences of still images, which are displayed on a screen on a television receiver, a television or TV, along with a synchronized audio, sound, channel. Television, video, signals occupy a wider bandwidth than broadcast radio, audio, signals. Analog television, the original television technology, required 6 MHz, so the television frequency bands are divided into 6 MHz channels, now called RF channels. The current television standard, introduced beginning in 2006, is a digital format called high-definition television, HDTV, which transmits pictures at higher resolution, typically 1080 pixels high by 1920 pixels wide, at a rate of 25 or 30 frames per second. Digital television, DTV, transmission systems, which replaced older analog television in a transition beginning in 2006, use image compression and high-efficiency digital modulation such as OFDM and 8VSB to transmit HDTV video within a smaller bandwidth than the old analog channels, saving scarce radio spectrum space. Therefore, each of the 6 MHz analog RF channels now carries up to 7 DTV channels. These are called virtual channels. Digital television receivers have different behavior in the presence of poor reception or noise than analog television, called the digital cliff effect. Unlike analog television, in which increasingly poor reception causes the picture quality to gradually degrade, in digital television picture quality is not affected by poor reception until, at a certain point, the receiver stops working and the screen goes black. Radio is a form of communication technology that uses electromagnetic waves. It sends and receives information over long distances. The history of radio can get traced back to the late 19th century. The Italian physicist and inventor Guglielmo Marconi invented the wireless telegraph. Marconi's invention paved the way for the development of radio broadcasting. It also paved the way for mass communication of information and entertainment. The inner workings of a radio station involve transmitting a signal from the source. In short, radio converts electrical signals into electromagnetic waves and vice versa. The invention of the radio has had a profound impact on society. It revolutionized the way we communicate and entertain ourselves. Thank you for watching this video.